Hello everyone, welcome back to Advent of Code 2024. We're going to start day 8 in a minute, but as often in these sorts of things, I have a small update to yesterday's solution. Where is it? Log? Yes. So I made two changes from where we left off. The first is I went back and turned things back into ints because we didn't need the integers after all. And also, I finally addressed how to. I didn't like. You will recall if you watched yesterday's video. I didn't like how in this function in solutions, or I guess in Go, I was checking whether the list of atoms remaining is empty, and then following through, like if we get equal and a non-empty list, I was checking, oh, is it empty? No, so don't return this. Fall through into this, and then immediately check atoms again and see, is it empty? And that's kind of wasted, right? So I realized that since I don't have a completely independent, I don't want to check two completely independent properties of whether we've hit the goal and whether the list is empty. Those two are sort of related. I need to compare to look at a combination of them. And so when that's the case, you can just you can do case match on a tuple of two things you care about, and then you can adequately express the conditions you care about. So if it's greater than, we don't care what atoms was. If it's less than and the list is empty, we return, we fail. If it's equal and it's empty, we succeed. And otherwise, then we don't really care. This matches basically either less than or equal. It would also match greater than, but we can never get here with greater than because we unconditionally failed greater than in this step. So this is basically handling the less than and equal cases. Each are kind of pattern matching the list once in a way. Yeah, that's sort of true. If it's less than, you check if it was empty and find it wasn't, and fall through to here. And if it's equal, you check if it's empty, and then if it wasn't, you fall through to here. And then in this case, we can assume that there's at least one item, and so this pattern match will succeed. We could even, does it make sense to I'm curious what's the deal with irrefutable pattern matches, because this is irrefutable, right? I could put a, let's look this up. Haskell irrefutable pattern. Yeah, so there's no real reason for this. The point of an irrefutable pattern is that it doesn't force evaluation of the thing you're matching. But we're evaluating it here. So it's the compiler's going to have to actually check that it's this anyway. Okay, not the compiler, the runtime. So anyway, that was the first thing I did. And the second thing was just a very small change. Wait, did I finish the first one? Yeah. Wait, oh. Oh, I'm right. I'm scrolling tmux instead of scrolling the git pager. Okay, that's why I was confused. Was switched to using non-empty because you'll recall one problem was that our program had a compiler warning, and it's nice not to have those, and I didn't think of any great ways to do it. The problem was here in solutions, we were assuming there's at least one item in the list because there always will be, but I couldn't prove it to the compiler, so it was warning me. And I didn't want to add in a case saying, oh, if it's empty, throw an error, when I know it won't be empty. So I hang out in the functional programming Discord, and most of the year I don't actually do anything there, but during Advent of Code I do poke around. And I saw someone who goes by Melissa there, and Melvar on GitHub had used not empty. And I remember I borrowed some stuff from her last year as well. And she gave me some advice about some improvements that I liked. So I think she's the only person who's been credited in my Advent of Code repo Git commits, and I'm crediting her again because I like the. I feel like she's the only other person using textreg explicative too. So clearly we would get along very well if we ever met. But anyway, so non-empty is a list with at least one element, basically. And so it's impossible to construct a non-empty with no elements. And therefore, the compiler, when you pattern match on a non-empty, it always has at least one item. The pattern match for non-empties is this here. The constructor is, we could even, actually, here's a good idea. If I say data list non-empty, is this going to tell me what it is? Yes. Yeah. Here. So non-empty of A is an A consed onto a normal list of A. So there's only one way to construct non-empty, which is calling this constructor, which requires one item and then a list of items. So when you pattern match on non-empty, you get back the first item and a list, potentially empty, of the rest of the items. But that way, you can guarantee the compiler there will always be one thing. So I had my equation, instead of holding a list of A, it has a non-empty list of A. And therefore, in solutions, we can match, and the pattern match is always guaranteed to succeed. And the only thing that has to change to give me the non-empty guarantee is just this line in equation, where instead of using many, I use sum1, which is a version of sum that returns a non-empty instead of returning a list, which is perfect. It's exactly what I want. So that's what I did. And it's guaranteed that sum1, again here, will never be called with an empty list, because sum1, is a function that, yes, it takes an alternative, matches one of those alternatives, and then any number of additional ones. And so if there isn't at least one, it will fail to match at all, and will return empty. Anyway, so those are the changes that I've made from yesterday. So now we can get on with day 8. Resonant collinearity. It almost sounds like it should be a reference to something, but I don't think it is. Anyway, you find yourselves on the roof of a top-secret Easter Bunny installation. While the historians do their thing, you take a look at the familiar huge antenna. Much to your surprise, it seems to have been reconfigured to emit a signal that makes people 0.1% more likely to buy Easter Bunny brand imitation mediocre chocolate as a Christmas gift. Unthinkable. Someone's sabotaging the Easter Bunny, huh? Scanning across the city, or the Easter Bunny is taking kickbacks, which we're not going to consider. Scanning across the city, you find that there are actually many such antennas. Each antenna is tuned to a specific frequency indicated by a single lowercase letter, uppercase letter, or digit. You create a map, that's your input, of these antennas. Tuned to a specific frequency. The signal only applies its nefarious effect at specific antinodes based on the resonant frequencies of the antennas. In particular, an antinode occurs at any point that is perfectly in line with two antennas of the same frequency, but only when one of the antennas is twice as far away as the other. Oh dear. For any pair of antennas with the same frequency, there are two antinodes, one on either side of them. Yes, I think I agree with that. So for example, if perfectly in line with two antennas of the same frequency, but only when one is twice as far as the other. So this is what in line, I think, with these two A's, but not twice as far from one as from the other, right? I'm sure they'll tell me if I read further, but I'm just trying to make sure I understand what I've read so far. At specific antinodes, yeah. So this is an antinode, I think. Well, no, I don't quite understand. This is an antinode, but it isn't one that is at the it isn't one of the specific antinodes? I'm not sure. Can we see any antinodes anywhere that do meet this property? Like here is an antinode and here of these two zeros, right? These two do actually meet this property. It's one away from this one and two away from this one, and here is the opposite. I feel like that's the only antinode in this whole input where that's the case. Unless they're saying that adjacent is actually 0 away, and I don't know, that doesn't seem right. These two, oh, inline as in if you drew a line between the two antennas. So that was another thing I was considering, although not actually. I was considering something different and wrong. Okay, so none of what I said is true. See, I should have just scrolled down, but you draw the line through the two antinodes. And then you kind of take the distance between the two of them and step that far in either direction, because that'll be when one is twice as far as the other, right? From here to here is distance x, which is like what? I don't know. Something with a root 2 in it, probably. 1 squared, no, it's root 5. 1 squared plus 2 squared, yeah, so it's root 5 away to here. And so when you step to here, you're root 5 away from this and 2 root 5 away from this. Okay. So that guarantees there always are exactly two antinodes. Not just like, okay, yes. So with my idea of perpendicular distance, that's in line with each of two antennas, but not exactly in line with the pair of them in a sense. And this antinode isn't guaranteed to be exactly distanced twice as far away from one as the other. With this concept, every pair has exactly two spots where this antinode occurs. Adding a third antenna with the same frequency creates several more antinodes. Yeah, so like this one goes to here. This one goes to here. Right. These two, there would be one like here and one here. But they're off the map. Antennas with different frequencies don't create antinodes. They count as different frequencies. But they can occur at locations that contain antennas. Sure. The lone antenna with frequency capital A, right. It can't make an antinode because there are no other capital A's, but this A casts an antinode on it. Okay. That's fine. So, at least for part 1, we don't appear to need an actual grid at any point, right? All we really need is a map from frequency, so like capital A here, to set of coordinates, being the list of places where there's an antenna of that frequency. Then we can iterate over each set, compute all the antinodes. We do also need one more thing, which is we need to know how big the map is, right? But we could. I think what would make sense is like to have a map from frequency to set of nodes, and then for each such set, compute all the antinodes that it would produce, regardless of whether they're in the map or not. And then outside, when we're like summing up, when we're like ready to compute the score for part 1 at a high level, we will both deduplicate all the different frequencies, the sets from each frequency, and also remove the ones that are out of bounds. That seems like a reasonable approach to me. And, I could not guess what part 2 is going to be, so I really don't know what flexibility to try to design to make part 2 easy. So let's just get started with part 1, shall we? Okay, there's my input. So I don't really need text regex. Just matching on lines is going to be simple enough. Line and zip is basically all I need. I guess I will need a strict map. I will want a set. I suppose I could use like v2 of int as my coordinate type, but I don't really need to do much math on them. Maybe I'll just I'll just see how unpleasant it is to, because like I ended up actually causing myself some heartache last time I used the linear v2 because I was like the concept of right hand was confusing, and I just was using concepts I didn't quite understand, I guess. So what if we said a data coord, or I don't know, data pair of A is a pair of A and A. Deriving. Now, I don't know. So this is the reason that so like I kind of do want v2 because I want to like be able to subtract two of these things from each other and add them to each other, and like you just get that for free when you use linear v2, right? Whereas like I would have to implement either monoid or which I could do, but I think what would make more sense here is applicative, and you can write like applicative instances aren't the biggest pain in the world to write. But it's just like, I don't know. If I had my own library for admin of code stuff, this would be in it somewhere, and then I wouldn't need linear v2 stuff. But I think it makes sense to just use linear here. Oops. And all I really need is v2, right? Pretty much. I get all the instances of like adding and all I really want is add and subtract anyway, I think. So type coord is a v2 int. Yeah, we're definitely not going to need integers for this. Int is fine. What type is my input? I guess it really ought to be a set of bounds. Well, not a set of, a pair of, you know, a pair of coordinates, right? The top left corner and the bottom right corner or something like that. So it's an input of oh, the funny thing is a pair of coordinates is a v2 of v2 of int, right? But I think that I will, for simplicity, just say it's 2 coordinates. I guess we'll want in range, I think is what that silly thing is called. Module data ix, class ix, yeah, in range, okay. So we'll get a pair of coordinates representing the top left and the bottom right, as if we were building an array. But we won't actually build the array. We'll just ask ix, like, hey, here's one coordinate. Is that within the rectangle defined by these 2 coordinates? So that's one of the things in our input, and the other is a map from, let's see, type frequency is a char. A map from frequency to frequency to set of coord. So I think that's the main type we want to work with for part 1 and part 2. And I think it's reasonable to write a parser for this now. I guess I want to, let's see. So a frequency is anything that isn't a dot or a hash, right? Okay, they say lowercase letter, uppercase letter, or digit. I guess we may as well go look at our input and see if it has anything that is... Yeah, I mean, it's all dots. Oh, right, there are no hashes even. So it's just anything that isn't a dot, basically, right? There's not like any weird... Well, maybe I had better be careful. Like, what if there's a % in here somewhere that I'm not seeing because I'm scanning it with my eyes, but it's actually there? Right? I should be careful and match specifically a digit or an int. So what's data char has functions for checking this kind of stuff. Character classification, control space, lower, upper, alpha, alpha num. Yeah, so alphabetic or numeric Unicode characters. So technically, is alpha num suggest like it also matches like Roman numerals or something, but honestly, if Eric put those in there to trick me, it'll be his fault when I don't succeed. So I'm going to just use this. I'll just use his alpha num for letters. What's the difference between uppercase and title case? Beats me. Okay. Yeah, so we'll use alpha num. Is alpha num? Yeah. And then if we get something that is neither a dot for empty space nor alphanum, we'll produce an error saying, hey, this does not match the problem specifications. Prepare. I'm already forgetting like the good way to parse grids. I did that in day 6 most recently, right? It's like not that hard, but indexed, yeah, so I have label lines of input. We do the zip with thing here. Sure, so, oops, so we already have indexed, I guess I want to, it's an input of length labeled, comma, that's our y coordinate. And it doesn't even matter what these coordinates are called, but, oh, hang on. It's an input of v200 and, because we have coordinates here, right? Yeah. And then length labeled, length of head of labeled. And then, so that's our bounds. Bounds antennas. Let's make that clear where bounds is this. Antennas is so it's a map. So I want m dot from list with s union. That seems right, because I'm going to be producing a set of antenna positions for each frequency. Of do, let's say. Pause. C comes from labeled, which we again haven't defined yet, but we will in a minute. Case C of, with a dot, nothing. So we will not produce an antenna in this case. If it's is alphanum x, it will be pure of, well, I guess I might as well just put it in a list. Same thing. Pure is just the singleton list here. Oh, actually, yeah, I do need a list, because we're doing a list comprehension here. I guess it's just the character is the key in the map, and the value is s singleton of the position. otherwise is error unexpected character x. Okay, that seems fine. Labeled. I guess I called it indexed in the last one, didn't I? Sure, that makes more sense. Indexed is... I don't have this label function, very confusing. I'll just say zip with lambda y r, zip with lambda x c is a v2 of, this time I'll do column major, you can't stop me, v2, yx, and c. Oh, but I have to match, let's see, it would be here. I mean, I guess I can just, no, I can't. Yeah, I guess I can A to reduce the R away, right? Zip with lambda xc, so we'll do that. And index also doesn't need its input. So, like, does any of this type check? How much have I forgotten to do? I always forget. I remember these days that when you use case, you use arrows instead of equals. I always forget, though, if you have a guard in a case, you still have to do that. Oh, I guess I actually do need to specify here because index isn't a function, it's actually a value of text. Zip with lambda list text, that seems fine. Okay, I'm too stupid to reduce this. Let's just put that R in. It's still broken. Oh, of course, this should also be a v2. Of course, inside of this, it should be, well, wait a minute. Oh. No, wait, what? That isn't what I was complaining about. Oh, pos C. We're binding indexed, right. So this should be v2. Should it? No. Because indexed... Let's put a type on indexed and see where my actual error is. Indexed is a... Oh, you know, I should be concatenating this somewhere, shouldn't I? No, I can't. But I can do it here, right? Because this is a list of lists, and I don't care anymore about that internal structure. I just want all the actual coordinates. This should be a little bit better, but still failing to compile, I assume. Okay, actually it's worse because I did that. Okay, now there's just one error. I have a list of B. I want a list of B, but actually I have a string. So I intend indexed to have type list of pair of coord and char. What do you think about that? How close am I? Okay, same error. So that's what it inferred from how I was using it. Of course. Not text, but the lines of text. I need this to be a list of list. There we go. Okay. Yeah, I mean, that's an okay type to keep around, I guess. So we should put deriving show on here. And let's just say prepare a read file input.txt. What do we see? What do you mean couldn't match type? Oh, right, of course. Not bind, but fmap. I always make this mistake for some reason when I want to play around in the REPL with the input. Okay. So it's from 0 to 50. Okay. Oh, although... Is it actually, though? I bet I have an off by 1 in here somewhere. Like, suppose there were 50 rows. If I called the first row 0... Yeah. I have to call it 1 because index is kind of 1-based. So from 1 to length, we'll have length items because the top and the bottom are both inclusive. So from 1 to 50, that means it should be there should be exactly 50 of these, right? Yeah. Okay, so we have at least done one thing correctly. We have parsed the bounds of the input. And then we say, 0, the frequency, has antennas at these 4 locations. 1 has antennas at 1, 2, 3, 4 locations. So this all... 2 has antennas at 3 locations. Okay, so they're not all the same number. They're all relatively small. Great. So you know what? Let's just commit that. Sure. Day 8, parser and types. So we can write part 1 now, I think. Part 1 of input of bounds and antennas? Is that a fair thing to call it? Let's call it freaks, I guess. Is let's see. Length of filter inbounds of toList, which I guess this is the toList from foldable. It doesn't really matter. S unions of antinodes. So is that right? That's what S unions does? It takes a list of things and unions them all? Yeah. So you could use, like, you know, foldar union or whatever, but S unions already takes a list of things, which is what I want. Where I guess I could say I don't really need this inbounds function, but I guess I'll define it. Like, it's just in range of bounds, but antinodes is, of course, the interesting function. Antinodes, it's not a function, it's a value here, but whatever, is do? Sure. I always have a question in my voice when I say do. It's just, it's so full of possibilities. How can do ever be wrong? So we want to... Oh, what is it? It's a soaks, that's right. Frequency and antennas will come from a soaks of freaks, right? I have this feeling that maybe for part 2 I'll care which frequency it was. And so I kind of want to produce that as part of the answer. And so, like, toList or S unions is going to be a little bit wrong. Well, maybe I'll just map. Yeah, I guess maybe right here I'll put map throwing away what the frequency is or something. But I don't know, this is all just inside of part 1. I'll do the thing for part 1, and if I need more stuff for part 2, I can add a little functionality while I extract this to a top-level function. That's fine. So I want a way to find all the pairs of two sets, right? Two antennas. I have a set, and I want all of the pairs from that set, but not including, like, an item paired with itself. And I mean, I guess that's fine. Let's just say A, B from will map tupling over I don't even really need this set. This could be a list. Why is it a set, actually? I mean, it is kind of nice for them to have a proof that they're distinct, I guess. There's not something interesting actually in set, surely, for this. No, okay. I want to call a function on. I want to call toList on antennas once, but I'm about to name it twice here. So I want to let something. I just can't think of a good name because I already used antennas. Locations be toList of antennas. So this is how you get all the pairs. Like you pair a list with another list. So this is okay. I mean, this is the list applicative. We've talked about applicatives before. We're using do notation on lists all the time, which iterates over them. But this is applicative notation for doing a similar thing, where this is going to produce a list of pairs. It'll choose one item from locks and then one item from locks independently. So it gives you all the Cartesian product, and then we'll call tuple on the results. So we just need to here say guard A is not B. We'll borrow that from. So now we have all of the, and like maybe you could do this in a more efficient way, but not much more efficient. So now I have a list of all the distinct. I have all the oh, this is wrong, isn't it? No, actually. Well, it is, but it's very easy to fix. The problem is this has a. Oh, you don't even have to fix it, do you? Because I'm going to put the result into a set. This gives me both AB and BA, and those will have the same pairs of antinodes. I could just continue writing this as is. Compute the antinodes for AB and the antinodes for BA, and they'll both go into a set, and it'll just be fine. They'll get deduplicated. But I can save some work by saying, instead of guard that they're different, guard that A is greater than B, and then we'll only get one of the two pairs. And because we're using v2, which I assume has an ORG instance, this is legal. You can compare, like right in Haskell, like this is not some special thing that only works on numbers. It works on anything orderable. And v2s of orderable things are also orderable, I assume. They must be, because we're putting them into a map or a set. So now we have this. Let's let. What's the word? It's like it's a vector. I have a vector from A to B, but like I don't know. It's the offset. It's the, I don't know, delta, delta equal. If A is greater than B, it doesn't matter because we're not actually worried about them becoming negative, but it just seems prettier to say it's A minus B instead of B minus A. And then we can just say, so if A is greater than B, we should add the delta to A and subtract the delta from B, right? Because A minus delta, yeah, B is A minus delta. You can do some algebra with the equation if you don't believe that, yeah. So B is A minus delta. So this is A minus delta minus delta. And this is A plus delta, which is going further away from B. Yeah, this looks correct. Now, I don't actually have any sets here like I thought I would, so I'm calling s.unions and toList for no obvious reason. I could just call like nub.ord. Or, yeah, I don't know. So what, is nub.ord in list or something, I assume? No, it's in data containers list utils. Yeah, so nub is a function in the Haskell standard library that takes a list and returns only unique elements from it. But because it only depends on equality and not sortableness, it can't be efficient at all. It has to be n squared. And there's a function like it in data, import data containers list utils nub.ord. Okay. I didn't know that package existed before. I just knew nub.ord was out there somewhere. And it's pretty much the only thing in that package. It has like 4 different variations of the nub function. It's probably more efficient to filter inbounds before we nub.ord, right? Because inbounds takes a small constant amount of time for each input. And nub.ord in principle like should take log of n time. This obviously is never going to matter for like real life performance on today's problem, but I think it's in principle better to order it that way. Oh, I have to say qualified somewhere. I forgot a qualified. Yes. God damn it. I hate this. I hate this language sometimes. These imports are so confusing. Because, like, this import that I've written here, and we're using GHC 2021. This is not, like, old-ass Haskell 98. This definition, this import, means import the whole thing, qualified as M, but, like, also just import the whole thing unqualified. Like, what the hell? Who would ever want that? Okay. Oops, the as should go here. Like, why do we even have that lever, right? Oh, wait, am I wrong? It was, okay, I'm wrong. Okay, never mind. It wasn't saying I don't know which one to use. It was saying there isn't one at all. Okay, toList from foldable, really? toList is not in the prelude, huh? Freak is not used. That's true. And intended. Okay. It compiles. What would you say we get? Well, let me run it. $351. Sounds plausible. That's the right answer. Cool. Yeah, actually. this should have been in the initial commit. There we go. Day 8, part 1. Did I call it 8? Yes, I had some brief thought that I'd accidentally written 7 in the last commit. Okay, what's part 2? Watching over your shoulder as you work, one of the historians asks if you took the effects of resonant harmonies into your calculations. Whoops. After updating your model, it turns out an antinode occurs at any grid position, exactly in line with at least 2 antennas of the same frequency, regardless of distance. What? Some of the new antinodes will occur at the position of each antenna. Exactly in line with at least 2 antennas. What? But I see. So it's like an infinite ray, or line, really, extending in both directions from... I see. So like this TNT creates an infinite list of antinodes like this until it falls off the face of the map. Okay, that's no problem. And also every antenna, which is still fine. Yeah, okay, no problem. Maybe this part 1 function should be extended somehow. Like, the only thing we really want to extract out is this. This needs to change into a way to generate an infinite number of the lists, right? So we want, like, antinodes from resonances. I don't know. Resonances takes 2 chords and also it needs a function. That's going to be this part. Turning something to list of chord, I think. So it takes a function producing like all the given 2 coordinates. Yeah. Well, the thing is, it doesn't really just want one of them, does it? I guess it... Okay. We can work with that. Yeah. Returning a list of coordinates. I mean, we kind of need the bounds as well, don't we? This is the worst. It doesn't take 2 coordinates. It takes an input. Right. Sure. I didn't need this bounds at all, actually, I didn't need to rename the bounds type. And int. So like we could honestly just call this like solve. So given a way to produce a list of coordinates from 2 coordinates, it solves the problem. And so most of this just goes here, right? Solve, extend, I guess? I don't know. Sure. And then an input is length, nubord. I think we can take out the inbounds from here because we're going to have to put it inside the loop. Antinodes. So we're going to do this whole thing. We look through all the frequencies. So part 1 is just solve of lambda a, b, a plus a minus b, right? So we get the delta. Yeah, that seems right. So we're going to have the new solve function take care of extending this in both directions. Or applying it in both directions. And it'll expect a potentially infinite list. So we don't need this delta here anymore. We've got two antennas, and we want to we'll pass extend. Take while inbounds. I really want this to be I want this more like valid extend a combined with valid of extend b where, oh, not where, put it out here. Valid now I don't need inbounds anymore, do I? Is take while in range bounds. Does that make sense? So extend A, giving us a list potentially infinite of positions. What's extend A? Are you insane? Extend A, B, and extend B, A. So like moving from, I think this makes, oh, I wrote A and it should be A, B. So treating, let's say, A as the root, or the origin, and extending by B. And then the alternative, treating B as the origin, extending by like the delta from A is the idea. So does this still compile? No. Why would you say that is? It is because I have not closed this parenthesis. Okay, now 351 is the answer I had before, right? I think so. So this is all still correct. We can say part 2 is solve. Oh, you know what? Let's be fancy. We'll use a dollar sign there. Solve of lambda AB iterate plus of A minus B A, right? So it produces A and then keeps adding the delta forever. Part 2 starts with B, yeah. And then it'll get flipped by the solve function. So this seems fine, right? 1259. Sure, it should be larger, but not by that much. I believe it. Well, was my answer 351, by the way? It was. Okay. That's the right answer. Nice and simple. Finally, one I don't feel like I blundered. It wasn't fast, but that's okay. Like it wasn't as slow as some of them have been. And I was, talking about stuff and doing things, defining the problem domain. I wish I could write this kind of prepare function faster, but it always takes me a while to churn through it. Yeah, I mean, I don't think there's anything else much to... It turns out we never did need to know what the frequencies were, so the map from frequency to set could have just been a set of sets, but, better to be prepared and have that information than to throw it away and then find out later you needed it. Well, I mean, actually... Couldn't I just throw away that change of naming bounds? Like, I don't use it anywhere else. We should still get the same answer after throwing those two chunks away. 1259, is that what I got? I've forgotten already. Yes, it was. Okay, so we didn't need to make that change at all. I just did it because for a moment I thought I was going to need the bounds type more than once. Yeah? A8 part 2. Great. So yeah, I mean, we did do, as I predicted I might, extract most of part 1 out into a public function, but I didn't know at the time what features I would need, so I didn't extract it until I needed it, and then I gave it the right arguments, which was, it turns out, a way to compute the antinodes. Okay, that's it for today. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.